marks. Okay, so we plan to have a first lab unit test immediately after completion of your CAA 2. Okay, ma'am. So be ready for that. If you want to get eligible to write the lab unit test, I told you already. Whatever the exam we have completed so far, all the submission work you have to complete. That is your observation and record. Okay. If we are teaching anything new after CA2, or between the CA2, you need to finish that particular observation work. Then only you are allowed to write for the lab exam. Let me check if there is any much pending in the lab observation work in both the classes. Lab observation. Can I see 1A itself? There are 11 students still. They are waiting to finish their work. Is this these students are present in this class? Please stay back. Please stay back. These 11 students, and as well as in the B class, these 9 students. Please stay back. We need to discuss. Okay, or else you can't complete it. I need a real difficulty what you are facing, why you unable to make the submission on this, because it is not possible you to complete all the your observation record works except Vignesh. Other students need to submit within a week, else it is I can't award the mark, and also you are not eligible to write your lab exam. Please remember. Okay, Vignesh, I told you to approach me personally. Thereby, we need to teach many things to you, but you are not contacting me. I gave my contact number also. You also having my number. Please stay back. At the end of the session, we will discuss. I need these persons to stay back. Okay, then we will discuss how to overcome that one. Okay, so with this, we will start the today's session. Before that, as usual, where we stopped our previous class discussion. Can anyone tell me? Okay, before that, is there anyone having difficulty in these submissions, quiz and lab? So எனக்கு வந்து மெயில் ஐடி வந்து erase ஆயிருச்சு, லாகின் இல்ல, பர்சனல் மெயில் ஐடியில தான் access. அது மாதிரி do you have any difficulties? I hope you don't have. Am I correct? So I think your laziness only make you to not to do this. Please kill your laziness. Okay, and start work. Yes. Now you tell me, before starting the today's session, what we discussed in the last class. I need only the title, what we have discussed. Can anyone tell me? What is our last class discussion? That is on Monday. Yes. Yes, sir.
Sir, biasing of E MOSFET.
Biasing of E MOSFET. Thank you very much. And also, I want to show.
Excuse me, sir. Sir, recording is happening only in one class. Is that enough?
Yes, sir. Enough, sir. Enough, sir. Sir, is it
okay,
is
sir.
it mandatory to put it in both the classes?
No, sir. I just asking.
No, sir. Sir, my drive is full. That's why.
Usually,
yes, sir.
You are recording in both of them.
Yes, sir. But nowadays drive full. Therefore.
Okay.
Yes, sir.
Fine, sir.
Yeah, thank you. And I want to tell you one thing. Next class I will show. Or at the end of the session I will show. You people are thinking, okay, I can show it from here. But if I show it from here, you will know the person. Okay. You people are thinking the online class is a difficult one, and many of them not listening the classes on, and we also no need to listen like that. You people were thinking, but I will show you the wonderful class note submission in our class, from our class. Okay, I have their class notes in my hand in the form of PDF. Next class I will show it to you how your class students are attentive in the class, and they know their responsibilities and they are taking the notes well. So who are doing this as a preliminary work in the regular classes, definitely they will get succeed. I will show you a few examples in the next class. Now I am not prepared. I don't have the file. If I open the file from here, you will know the person's name. Without identity, I need to show the files. So next class, I will show to you people. Okay, they are doing excellent work. I'm really happy. I didn't return all the things, but we are watching what you people are submitting. Okay, yes. Okay, we'll start our discussion. Last class we completed E MOSFET biasing. Am I correct? In E MOSFET biasing, can anyone tell me how many types of biasing available in E MOSFET, sir? E MOSFET எவ்வளோ biasing types இருக்கு? Hello? E MOSFET.
Two types.
Only two: drain to gate feedback biasing and voltage divider biasing. Okay, is it this voltage divider biasing is new to us? Is it the voltage divider
No,
biasing?
sir.
No,
No,
where
sir.
we have studied already? Where we have studied already?
BJT, sir.
Yes, in BJT.
BJT.
BJT itself we have studied, and also we concluded in the BJT itself the voltage divider biasing giving good stability than the other biasing methods. Am I clear? Yes. Then we discussed what are all the circuit are set up. Then we did some analysis in input output circuit. From the help of these analysis, we found the what? We found what? From why we are carrying why we carried out these analysis? Why we carried out these analysis? Anyone? What is the purpose? So this is to see if you closely observe these equations, these are all some design parameters. That means what? VGS, VDS, VGS, VDD, ID, RD. These are all few things I need to keep in mind whenever I am designing the circuit, because in this circuit you are only going to apply the VDD, okay, and you are going to design the drop across this terminal, okay, by properly designing this resistor values. Okay, so by physical construction you will buy this MOSFET, then you will get these two resistors. Simply you can't take any resistor value, because in market you have a lakhs of resistor value, start from even fraction of values 001 ohm it is available up to mega ohms. So what value of resistor I need to put it in my circuit? That and all you need to decide with the help of these analysis. Okay, this analysis impacts in one thing. It's a very important thing related to your operation. Can anyone tell me what is that? What is that? What is that? We will draw one more line in this. We will draw one more line in this. Then
DC load.
okay, then that line will intersects
Q point.
Q point, sir.
Q point.
That is your operating point. So this is very important. Okay, so if you design the operating point, as a designer you like to play only within the tolerance of this. We can move up to this, we can move up to above this, below this. There is a tolerance level. But if I'm designing somewhere here, but it coming here and it go back here, that means what? There is no stability in your design or the circuit. Okay, so if this Q point varies, obviously my performance will vary in the particular circuit. Okay, so that is very important. So these things we have discussed, then followed by voltage divider biasing also we have discussed. This is our input circuit analysis, output circuit analysis, followed by your operating point. That's all. And few analytical sums we have discussed, and we gave two homework sums to work. In the homework sum we gave the question as well as the answer. Am I correct, sir? Try பண்ணமா அது வருதான்னு சொல்லி. Is it you have tried this question? If anyone not tried, at least try it today. Okay, because here you have different quantities, mega ohm, kilo ohm. Okay, if you practice, if you calculate with the help of your calculator, then only you know how to substitute this in your calculator. Or else during examination you will substitute any one ஏதோ ஒரு எடுத்து வேல்யூ எடுத்து சப்ஸ்டிட்யூட் பண்ணி ஆன்சர் வந்துருச்சுட்டு ஓடி போயிடுற. Okay, don't do that. Practice it properly. You have an answer to check by yourself. Okay, then here also if you calculate this, you will get something in your calculator with a very bigger magnitude. You should know how to convert the bigger magnitude to mega ohm. Once you calculate it by yourself, then only you can do it. These mega ohm, these bigger values are not possible in calculators. Sorry, manually, it is not possible. Even our unit test 2, I am finding this kind of calculation. Can anyone tell me what it is? What it is? இது என்ன calculation தான் சொல்ல முடியுமா? இப்படி இப்படின்னு போட்டு நிறைய எழுதியிருக்காங்க. இது என்னது இது? What is this? What is this? What is this? Division, correct? இங்க உட்காந்து manual division போட்டு உட்காந்துட்டு இருந்தீங்கன்னா 2 மார்க்குக்கு how you will go to the part B question? At the end, if we watch, they wrote only one big question in the part B. Why? You consume lot of time in the part A itself. And also this, இது மாதிரி போடுறாங்க. What is this? இப்படி எல்லாம் போட்டு எழுதுனா என்ன நடக்கும்னா இப்படி இப்படி போட்டு எழுதிட்டே போனா what is this? LCM. LCM and division we are not going to give any mark. Okay, these steps, even if you do it in rough work also, don't we won't bother. We need only the end result and the proper substitutions. But you people are spending much time in these kind of calculations. Thereby you will lose your chance to attend the part B questions. Okay, please avoid these practices till at least you get some basic calculators and practice these things. Okay, yes. Now we will get into the D MOSFET. The last class itself we have given some introduction about the types of biasings available in the D MOSFET. What is the today's date? We got 30 more pages in our life. That is your என்ன month இது? June. So June la date 2. Am I correct? Yes. So don't waste the days. Utilize it properly. Okay. Yesterday what you did I don't know. You learned something yesterday. Today we are going to learn this. Okay. So D MOSFET biasing. Why I need to learn about this? So from the construction wise, E MOSFET and D MOSFET having little changes. Am I correct? Thereby there will be a slight modification in biasing also. Okay. How many types of biasings available, sir, in D MOSFET? Can anyone tell me how many types of bias? Three. Have you browsed anything related to the three? எங்கயாவது எடுத்து பாத்தீங்களா? Circuit எப்படி இருக்கும்? Can you remember the circuit? Circuit எப்படி இருக்குன்னு தெரியுமா சார்? Let me show the circuit in a single page. You too note down the circuit in the single page. Thereby you can compare and study the things. Okay. Yes. What about the first one? What about the first biasing? Fixed
Gate bias.
or gate bias. Fixed or gate bias. Okay. The second one. What about the third one?
Voltage divider bias.
Voltage divider bias. Very good. Okay. We will go from this direction because I know this one very well. Am I correct? Voltage divider biasing. Any idea why the scientists gave this name to this biasing? Why it is called as a voltage divider biasing, sir? So instead of representing this VDD, I can mark like this. I can connect the source in this terminal VDD. Am I correct? Now you tell me why it is called as a voltage divider biasing. Okay, or otherwise, which elements will help to divide your input voltage? This is my input voltage. Am I correct?
Resistors R1 and R2.
These series resistors will help to divide my input voltage into some value. Okay, and that too, the drop across R1 or R2, which one aids to bias R1 or R2? The voltage drop across R1 or R2. Which one?
R1. Sir.
Is it R1? Is it R1? Okay. Biasing means the DC external voltage applied across your the control terminal and the other terminal. What is the control terminal in our device? It is a gate. In case of transistor, which one is the control terminal? Which one will control the device operation? That is your base. Am I correct, sir? In case of transistor, always you need to focus on the third terminal, control terminal and the other terminal. அதுக்கு அக்ராஸ் என்ன இருக்குன்னு பார்த்தேன்னா, especially this kind of biasingல the gate to source voltage, this plays the biasing role. Am I correct? So if a voltage drop across R2 is going to provide the biasing voltage. Is it clear? Is it clear? This is very clear to everyone. No need to confuse lot. But I need R1. R1 will take something and it will give remaining to the R2. That is 8 going to trigger your device. Okay, that is regarding your voltage divided biasing. So it is very much very similar to all the types what we have studied so far. Okay, then now we come to self bias. Self study. Self study means what? Yourself you will read something and you will understand. Am I correct? Similar way, in this biasing, can anyone tell me why it is called as a self bias? So bias means immediately I need to focus this zone. Am I correct? Focus this zone. Is there any source present here in this terminal? That specific or source irukka inga? Is there any DC source present over here? Yes? Yes or no? Okay, before that you check it here. This is called fixed or gate bias. Here I am having one fixed voltage source at the gate terminal. Am I correct? So this source is going to bias. This source is going to bias my circuit. Therefore, it is called as a fixed or gate bias. So the fixed voltage I am going to keep it in this gate terminal to bias. Therefore, I can spell it as a fixed or gate bias. But if you check this diagram, you don't have any additional source over here as like a voltage divider. But here I am not going to divide the voltage. See, actually this is the real diagram how we will construct. Okay, so in the VDD inga irukum source. So if you closely observe the diagram, so here I am going to give the input supply, then the current flow will actually இப்படி reverse la irukum, inga minus inga plus, current flow in the direction la கொடுத்திருக்கு. Correct? So it will flow like this. In the same, in the particular source is going to give some potential drop across this too. Correct? Additionally, we are not going to give anything. Okay, in the zero potential, we are not going to straight away give it as a 0 volt. We are dropping into some level. So in the terminal valiya, it is going to give some potential. So in the gate kum idukkum measure panni paartha, there will be a potential difference. That is VGS. That VGS going to aid my biasing. So since it's a voltage control device, always I need to focus VGS in all the diagram. So how much VGS you are going to give, that much proportionally it is going to make the conduction in your device. Okay, so VGS you need to focus in all the diagram. So it's very simple. Here I am going to divide the voltage. Here I am going to give separate source. Here I am not going to give any separate. The circuit itself going to bias with the help of one small resistor. Okay, so we are not to bother about the resistor values much, but the name of the resistors you do remember. Okay, it is very simple. If you find the terminal name, the resistor name also same. Source. So here alone there is a little difference. Now on all the things, T na inga D irukum. Here if you have S, G na G, D na D. So you don't need to memorize. Only you need to remember the construction. Then remaining things you can draw by your own. Okay. So please have the comparison. இப்படி ஒரு டேபிள் வச்சுக்கோ 3 டிவைட் பண்ணிக்க நோட்டை ஓகேவா டிவைட் பண்ணிட்டு whatever thing we are going to discuss please put it in the same tabular format, thereby during examination you can compare and study. Okay, yes. Now we will get into the analysis detail. Sorry, yes, the first one is the fixed or gate bias. I hope everyone have the circuit diagram. Is it I need to give a time to draw? Yes, fixed bias. Okay, time வேணுமா draw பண்றதுக்கு? Yes, yes, okay. Can anyone tell me immediately after having the circuit diagram what we will do? Because we need to find the Q point for the particular biasing. Can anyone recollect the last class procedure and tell me what is the first and foremost procedure I need to do to find the Q point? Yes, this is my circuit diagram. I need to do a little analysis. What are the analysis we will do usually?
Check KVL equation.
KVL equation for
Input and output.
this zone is or this loop is called input loop.
Input.
Where is the output loop? Where is the output? You need a closed path. Okay, that is considered as a loop. Where is the next one? This one. Am I correct, sir? This is your output. Correct? Sir, என்ன சார் ஒரு சிங்கிள் ஒயர் மாதிரி இருக்கு இது எப்படி லூப்பா க்ளோஸ் ஆகும் அது எப்படி க்ளோஸ் ஆகும் சார் how it will get a closed path so இது
ground terminal
எப்படி how it will get a closed path single lineல இருக்கு சார் how it will get a closed path actually the VDD ன்றது ஒரு source we have connected like this correct now you check are you getting on closed path are you getting on closed path am I clear this is one path this is the second path okay wow. So we are simplifying the diagram not to have a much branches therefore we are focusing on the simple notations that is we are going to mark only the name of the voltage source connected in the particular terminal okay wow. Yes, now you tell me can you make an attempt to write the KVL equation for input and output circuits? Please take 1 minute time and try to finish. Yes, yes. Which one easy you to write? I can you can make an attempt in both the input and output. Make an attempt yourself and then we will check your answers. Okay. Yes. Okay, let me take the input first or output first. Which one you want? Input or output? Okay, let me take output. Input எடுத்துக்கலாமா? Okay, input. Okay, listen. This is VGG. Correct? VGG is the input voltage. How you will write VGG? Whether you will write it as a VGG plus or VGG minus. See the polarity and tell. VGG plus. I am considering this as a current direction. Tell me. VGG plus or VGG minus?
minus sir.
Minus VGG is equal to. Minus VGG is equal to. Continue. Minus VGG is equal to. This is the input. This is one drop. This is the second drop. Here there is no drop. Why? Why? It is simply a conductor. Am I correct? There will not be any voltage drop here. So I need to focus only these two. Tell me. What is the drop across this? That is the current through the resistor and value of the resistor. Let me write the value of the resistor. You tell me what is the current through this resistor? This is any terminal.
IG, sir, but
Ah,
IG equal to 0, sir.
okay, IG is 0, very good. Anyhow, we will keep it IG in our equation, then we will eliminate. Then, what about this drop? What about this drop?
Sir, minus VGS, sir.
It is not, I see, it is not, I'm going
This is plus VGS, sir. Plus VGS.
plus
Sir.
VGS. Yes. As your friend told already, the gate current in MOSFET is approximately 0. Thereby, I can eliminate this drop. Am I correct, sir? Thereby, I can write the equation as VGS equal to minus VGH. How simple it is. The input equation over. Okay, make an attempt for the output, please. Make an attempt for the output circuit. Output circuit, which one is the source? VDD. Okay, put the source one side and mark the drop in the other side. VDD is equal to, this is the first drop, this is the second drop. Very simple. Tell me.
So
ID or
ID
plus VDS.
Very good. ID or D plus VDS.
VDS.
Is it clear? Shall we check our answers? Shall we check? Yes, now we will check our answers. First one, input circuit analysis. Yes, VGS equal to minus VGG. How? This minus VGG. These things, usually we will keep it in the right hand side. If you bring it to left hand side, you need to change the sign. Don't get confused with this. I hope you clear about this one. Am I clear? You can write it as a first step, and if you want, you can rearrange it like this. It is not mandatory. Okay, then why the drop across this resistor is 0? Because
IG.
IG is 0. Adum clear. Then VGS equal to minus VGG. This is the finding from this input circuit analysis. Then here they gave one more thing, VS equal to 0 volt. That means what? If I connect any voltmeter across this, there is no potential difference between these two terminals. Am I correct? Since I don't have any resistive element or any inductor or capacitive element, there will not be any drop in this conductor. Thereby, the voltmeter will show only 0 as a deflection. Here they marked it as a VS equal to 0. So input circuit analysis over. Output circuit analysis, check it. Yes, that too correct, sir. Check it, that too correct. VDD. Yes, VDD, then this drop and this drop. Both the drops are present over here. Okay, so VDS is equal to VDD minus IDRD. That's all. Any doubt in these equations? Any doubt in these equations?
No, sir.
Next thing is we need to draw the find the DC load points. But in this analysis, it's very simple that since you don't have any current element in this equation, you will be having only one point. Okay, ID in the ID VGC substitute we will get a 2 load points. Here you are having only one point, that is this VGSQ equal to minus VGG as per this equation. Am I correct? Just now we have derived VGS is equal to minus VGG. So here, which one is absent? Current component is absent. So thereby simply I can find it as a single point. Then in the point in the particular parallel, I need to draw one line. So parallel, if I draw the line, it will hit the transfer characteristics here. So this is the intersection point. So intersection point is nothing but my operating point. Is it clear? The current corresponding to that point is your IDQ. The voltage corresponding to that operating point is called VGSQ. So the coordinates are VGSQ, IDQ. I hope this is very simple. Please note down, and if you are completed, please say yes. We will move. Yes. Next biasing என்னது? What about the next biasing? Shall we move? Yes.
Yes, sir.
Okay. Yes. Now we will move to the self bias. Again, I don't need to tell anything. Yourself, you can write the input and output KVL equations. Then we will check the operating point. Here you do one thing. Here you do one thing. Okay, this is your input loop. This is your output loop. Okay. Yes. First, we will write output equation. VDD is equal to what?
IDRD plus
VDS.
plus IDRs.
IDRD plus this drop VDS. Okay. Then this drop.
Plus IDRs, sir.
ISRS.
ISRS. Actually, it is ISRS. You know well. The drain current and source current are equal or same. Why? Since your gate current is 0, it won't get diverted in the second branch. Okay, thereby you can rewrite the equation as a IDRT plus VDS plus IDRS. So if you want to simplify the equation, you want to take a ID as a common, that and all you can do it. Okay, now you come to input. So input la, is there is any source present? No source. Correct, sir? No input source. No input source na left hand side enna ponnum?
0, sir.
0 is equal to, tell me, what is the first one? This is the one drop. What is
IGRG
IGRG? Okay, then
plus VGS
VGS.
plus ISRS.
Let me keep it as a common term ID.
IDRD.
ID or yes.
RS.
And the ID in the resistor. We are focusing on this resistor. Okay. In this, which one we can eliminate, sir?
IGRG, sir.
This term we can eliminate. Thereby, VGS equal to what?
Minus IDRS, sir.
That's all. Shall we check our answers?
Yes, sir.
Yes, we will check. The first one, input circuit analysis. Yes, perfect. The input circuit analysis, VGS is equal to minus IDRS. Correct. Okay. Then output circuit analysis. Yes, they did the same thing. VDD is the input. Then 3 drops: RD drop, VDS drop, then RS. So IDRD, VDS, IRS, 3 drop. Okay. Then if you rearrange and 2 magics, you will get this as an entry. Please take down. I hope this is understandable to everyone. Repeatedly we are getting only 2-3 responses. I hope others also understood. If you people are finding difficulty to write this equation, please stay back and clarify your doubts, then you go to your lunch. Okay va? Our answer சொல்லிட்டு இருக்கான், அவர் பாட்டு கிளாஸ் எடுத்துட்டு இருக்காரு, நம்ம பாட்டுக்கு படம் பார்த்துட்டு இருக்கலாம், இன்ஸ்டாகிராம்ல ஸ்டேட்டஸ் பார்த்துட்டு இருக்கலாம், ஃபேஸ்புக்ல பார்த்துட்டு இருக்கலாம், டெலிகிராம்ல பார்த்துட்டு இருக்கலாம். அப்ப என்னன்னா, whoever answering now, அவன் 4 வருஷம் கழிச்சு அவன் இதை நீ இப்ப பண்றதெல்லாம் அவன் பண்ணிட்டு இருப்பான். அப்ப நீ என்ன பண்ணணும்னா, கோச்சிங் கிளாஸ், அப்புறம் என்னது பிளேஸ்மெண்ட் கிளாஸ், ஆப்டிடியூட் கிளாஸ், இது மாதிரி ஒவ்வொரு கிளாஸ் அட்டன் பண்ணி again you need to enhance your knowledge, then only you get into the industry. So which one is good? After 4 years getting into the some work is good, or after 4 years you are feeling that you don't have enough knowledge, then you go back for some other training and you want to spend money as well as your valuable time. அப்புறமேல் திரும்ப இங்க வந்த அப்படின்னா உங்க கூட படிச்சவன் அங்க பாத்தீங்கன்னா உனக்கு மேல இருப்பான் பாஸா. தயவு செஞ்சு இன்டராக்ட் பண்ணு, லிசன் பண்ணு. I hope you know these equations are nothing but your arrays. Arrayல ஸ்டோர் பண்ணி you are going to write the coding to do the things. Okay, கொஞ்சம் ரியலைஸ் பண்ணிக்கோ, ப்ராக்டிஸ் பண்ணிக்கோ, அவுட்புட் கிரியேட் பண்ணு. ஓகே, I think I couldn't give any task for a long time. Today note down the task. D MOSFET, E MOSFET, biasing. இங்க ஒரு 2 biasing, இங்க 3 biasing. You put together, if you take 1, 2, 3, 4, 5 switch cases or any other new technique you know, adopt it and design and send it to us. Okay, I hope you can do this one. So if you do that, you can check these answers. The answer la nee check panni paakalam, correct? And also you can give the options to create the cue point also. Try pannalamla, you can try it yourself and find it. Whoever know Python, they can feed these values and get this plot. Okay, any other graphical tool if you know, also try. Whatever thing we are discussing, take these table readings, feed it into your coding and try to get this response. If you are getting this perfectly, you are trained in 2 things. One is in the device, another one is your coding. Okay, so mutual benefit. Okay va, try panni paar. Yes, now we will come to where the okay, we need to discuss that operating point. Am I correct? Yes, come to the operating point discussion for the self bias. So take this equation. In this equation, what we need to do, usually what we will do, ID 0, then VGS 0 ponnu, correct? Substitute panni we will try. Okay, but there is one little deviation here. Here in this we are going to substitute only ID value in the biasing. Okay, ஏனா ரெண்டுக்கு 0 போட்டனா whole term 0 ஆயிரும். Okay va, you can't find the second point, so thereby first case la you are going to substitute ID equal to 0 as usual. Okay, second case we are not going to put VGS is equal to 0. Instead of that we are going to use ID is equal to IDS by 2. Thereby you will get 2 operating points. With the help of these 2 operating points, can anyone tell me 0, 0 means where your point will locate in your transfer characteristics? I think this is your transfer characteristics. Am I correct? Where this point
Yes,
will
sir.
locate 0, 0.
Origin.
Origin, sir.
Exactly in the origin. Very good. Just that the second point will fall somewhere. Okay, please check the magnitude. This is your VGSQ, correct? This is your VGS line, this is your ID line. So ID line la IDS by 2. So IDS by 2 na this the IDS, idla half edutha inge varum, correct sir? So inge இந்த இடத்துல ஒரு இங்க வரும். Then அந்த இன்னொரு பாயிண்ட் என்ன சொல்லிருக்காங்க, IDS into RS by 2. அப்ப அது இங்க வரும், ரெண்டு பாயிண்ட் இங்க வரும். இது ரெண்டு டச் பண்ற இடத்துல செகண்ட் ஆப்ரேட்டிங் பாயிண்ட். If you join It need not to be in the line. Sorry, in the line இருக்குன்னு அவசியம் இல்லை. எங்கேயாவது ஒரு இடத்துல அந்த பாயிண்ட் கிடைக்கும். So if you connect these two, this will be the intersection point. Clearly you can see it in the slide. Can you catch these 2 points, sir? One is in the origin, another one is somewhere. If you join these two, sorry, if you join these two, this is your operating point. Okay? Any doubt?
No, sir.
No, sir.
Yes. So the transfer characteristics is the fixed one. The biasing will change this line, that is your DC load line. Based on the DC load line slope, operating point will vary. The designer need to take care of the proper operating point for the particular operation. அது வந்து saturation இல்ல switch act ஆகுதா இல்ல amplifier act ஆகுதா, based on the application you need to find this. Yes. Now the last one, last but not least, yes, here a little magics you need to do, but you are well versed. You can revise your knowledge by doing yourself. Can you make attempt of this? Let me help you to write the equation. This is your input portion, this is your output portion. Yes, write it yourself. Yes,
Sir, input is equal to 0 is equal to.
சித்தேஸ்வரன் ப்ளீஸ் 2 minutes வெயிட் பண்ணுங்க.
Sir,
வேற யாராவது ஒருத்தவங்கள்ட்ட ஆன்சர் எதிர்பார்க்கிறாங்க. Can whoever not answered so far make attempt. You people keep quiet and check the answer alone. Okay, if we are making any mistake and tell us. Can I இது வரைக்கும் attempt எடுக்காதவங்க எடுங்க பார்க்கலாம். Yes, யாராவது ஒருத்தவங்க கூப்பிடுங்க பார்க்கலாம். யார் இருக்கிற கிளாஸ்ல? ரொம்ப நாளா கிளாஸ் சைலண்டா போயிட்டே இருக்குது. சிவபிரகாஷ் இருக்கீங்களா? சிவபிரகாஷ், தீபன் ஆகாஷ். எஸ், ஆன்லைன் கிளாஸஸ் வந்து ஒரு என்ன சொல்றது, ஒன் வேலயே போயிட்டு இருக்கு. 1 or 2 நிறைய பேர் வெளியே ஓடுறான். 235 பிரவீன்குமார் எதுக்கு வெளியே போறாரு? நம்மளை கேட்டுருவாங்களா அப்படின்ட்டு ஓடுறானா? இங்க தனுஷ் கிளம்பிட்டாரு. எஸ், இளமதி இருக்கீங்களா? இளமதி. லக்ஷனா இருக்கியாமா? எஸ், சிஏனா ஒருத்தவங்க ஆன்சர் பண்ணுவாங்க, அது யாரு? அந்த நிரஞ்சனா இருக்கீங்களா? நிரஞ்சனா,
Yes, sir. Yes, sir.
can you make attempt?
Yes, sir.
இன்னொரு கிளாஸ்ல யாரோ கூப்பிட்டேன், யாருமே ஆன்சர் பண்ணல. ட்ரை பண்ணுங்க நிரஞ்சனா, தப்பா இருந்தா தப்பே இல்லை. which one you will try, input or output? அவுட்புட் எடுத்துக்கிறீங்களா?
Yes, sir.
Okay, tell. VDD is equal to
ID or D
ID or D, very good,
plus VDS
plus VDS. Okay,
plus IDRS.
that's all. As simple as that. Is it everyone getting this equation, sir? Is it everyone getting this? Is it everyone getting this? How you can rewrite? You can take this ID as a common and you can rewrite. Okay, very good, thank you. Okay, can I input? Who is going to make attempt for the input? Input, I will tell you one thing. For input, you no need to worry much. Consider this voltage as a VG and write equation. Don't bother about this drop and all. Else, if you are well versed, sir, let me consider this drop. Let me consider take as a VG as an input and start spell your equation. Anyone, please? VG. How many drops were there? VGS there. Then the drop across this resistor. Try பண்ணலாமே.
IDRS.
Tell me, what is the first one? VG equal to
VGS plus IDRS.
ஆதித்யாவா?
No, sir.
யாரு?
Samrita, sir.
இவ்வளோ நேரம் எங்க மேடம் இருந்தீங்க? நம்ம கிளாஸ்ல தான் இருக்கீங்களா? அவன் வந்து தேடி கண்டுபிடிக்கும் போது சொல்லிக்கலாம் அப்படின்னு உட்காந்துக்கிறது அப்படிதானே? சரி, ஓகே. Can I sit correct? Okay. Samrita, please tell me how to find VG. Any idea? How to find VG? Please turn your pages and find it. How to find
VDD by
wait a minute. This is the voltage I need to find. So VG is nothing but the drop across this resistor. Am I correct? So how to find the drop across this resistor? The current through this resistor multiplied with the value of the resistor. So please tell me in the same fashion. First tell me what is the name of the current. Current we don't know, we need to substitute something. Thereby we will take our resistor value first. Okay. Then how we will find the current through this? Total input voltage divided by sum of these two resistors. Am I correct,
two
sir?
resistors.
Am I correct? இதை நம்ம உட்காந்து மாப்பாடம் பண்ணணுமா? வாட்ஸ்அப்ல பார்த்து காப்பி அடிக்கணுமா? இல்லை நம்மளே எழுதிடலாமா? We can write it by our own. Am I correct? Yes, thank you. Now we will check the answers. Okay. Yes, it's perfect. VGS. Where is the where is the VGS? In the equation பார்த்தா ஈஸியா இருக்கும். VG. In the VG, this is one drop. This is one drop. This is the second drop. That's all. From that equation, if you rearrange the things, you will get this as the intercept. Then, how to find VG? So this is the formula. Very simple. The value of the resistor and current through the resistor. I hope it is clear to everyone. And also, anyone can tell me why it is, IG is equal to 0 ampere in MOSFET, don't worry. What about this? Why it is IR1 is equal to IR2? Can anyone justify why IR1 is equal to IR2, sir? In the same way we discussed one more thing. Same way we equated to two more currents. Can you remember what is the two more current we have equated little slides before?
IDIS.
Very good. IDIS. In which by having this single assumption, even you can remove this branch whenever you are writing the equation, because in this branch there is no current flow. But whenever you are writing KVL, that time you need to remember this loop. Okay. If there is a break, you can't write the loop. Okay, ma'am. For current, whenever you are thinking about the current, you can ignore this branch. So current through this IR1 exactly equal to IR2. It is very much similar to current through the source terminal is equal to ID. இதே assumption தான் இங்கேயும் applicable. Okay, that's all in the first line. Now we will see the output circuit analysis. Is it your friend's statements are correct? Please check it. VDD, yes, that is input voltage. Then first drop, okay. Second drop, okay. And third drop. That's all. Okay, sir. Please take down. Please take down this. Okay, what will be the next step to us? What we need to do?
Draw DC.
Draw the DC load line. Very good. Draw the DC load line. Please say yes if you have take down this. Yes. நான் இவ்வளோ டைம் கொடுத்து எழுத சொல்றோம், நீ கிளாஸ் நோட் சப்மிட் பண்ணாமையே தூங்கிட்டு உட்காந்துட்டு இருந்தேன்னா கடைசியில அட்ட ஸ்ட்ரெச்சில் அப்புறம் ஹோல் நோட்டை நீ தான் உட்காந்து ஸ்கேன் பண்ணணும். புரியுதா? இந்த மாஸ்ஃபெட் கம்ப்ளீட் ஆயிடுச்சுன்னா மாடியூல் 2 முடிஞ்சிடும். ஸோ அப்போ we will check whole the things up to module 2. கொஞ்சம் இது வரைக்கும் நோட்டே போட்டு எழுதாதவங்களாம் கொஞ்சம் எழுத ஆரம்பிச்சுக்கோ. அப்புறம் நான் லாஸ்ட் மூமெண்ட்ல ஸ்ட்ரிக்டா பிடிக்கும் போது அப்புறம் எல்லாத்தையும் உட்காந்து எழுதுற மாதிரி ஆயிடும். சரியா? Yes. Shall we move? Yes. DC load line. So DC load line, this is the equation. In this you need to substitute ID equal to 0. ID 0 na enna sir agum the equation? ID equal to 0 na?
V equal to
VG. Okay. VGS equal to 0 na enna agum?
VG equal to IDRS.
Check this whether this is correct. These two load points, VGS equal to VGG if ID equal to 0 means, similarly ID is equal to VGG by RS if VGS Q is equal to 0. So we found two load points. So these are all the coordinates. Using that you can point those points in your transfer characteristics. So what is the first point? VG ID 0. So that is this one. What about the second one? ID is 0. Then VG is having sorry.
So VGS is 0
VGS
and ID
0,
is
yes.
VG by RS.
VG by RS. Can anyone tell me where is that point? This is VGS 0. Correct, sir? But this is my
Yes, sir.
So if we connect these two, this is your operating point. 2 point. That's all. Okay, what about the next biasing? Do we have
That's all, sir.
That's all. Very good. So 3 biasings, 3 DC load lines. So அப்ப என்ன பண்ணணும், you people, I hope you people written in the comparison table மாதிரி எழுதிருப்பேன்னு நினைக்கிறேன். Then only you can compare, you no need to turn your pages. Okay va? So in the same thing you continue பண்ணி have your remaining discussion also in the same tabular column. It will be very, very good for your understanding wise also. You can easily understand and you can easily compare the things. What is the difference between this and this and this? Then likewise you can extend your comparison table. You can extend your comparison table to what? This is for D. Put E. And even you can include your BJT. So single sheet la you can finish your module 2. Okay. So likewise, if you have 2-3 sheets, the whole thing will get finished. Okay. So try to have this kind of techniques. இந்த soft copy இது மாதிரி ஏதாவது create பண்ண முடியுதா? Create பண்ணி வச்சுட்டு go through it. Yes. Now we will get into the next topic. Before that, we need to ask one thing. How we can revise the CA1 portion? Sorry, 2 portion. CA2 portion every revise பண்ணலாம். Is it I need to take once again, or as usual can you take seminar on one day? என்ன பண்ணலாம்? இல்ல உங்களுக்கு ரிவிஷன் வேண்டாமா? எது சொன்னாலும் ஓகே. Is it possible you to recollect the things and you can reproduce it? Illa, if you want to revision, it means mostly I am not going to give revision. Okay, you people are going to present. If so, whoever having the laptop in both the classes, I need minimum 3 persons in each class. Okay, if you stay back, I will give you the title. If you don't have we will find some solutions. Okay, how to make a seminar class. Who were not presented so far, you have the higher priority. Okay. Shall we have one seminar class before your CA2? Else yourself you can study. Open your mouth and tell. என்ன பண்ணலாம்? Else we will go as per our schedule. Today we will see one application. In next class we will see the same application in the detailed way. Which one you want? Please unmute and tell. Any answers? Do you need a 1 hour revision or continuous class? Yes or no? என்னடா எல்லாருமே தூங்குறீங்க? Hello? Can I please type it in the chat box if you need a revision? Type பண்ணி பார்க்கலாம் yes or no. கொஞ்சம் குயிக்கா. கொஞ்சம் இது நாள் வரைக்கும் chat box யூஸ் பண்ணாதெல்லாம் கொஞ்சம் தேடி கண்டுபிடிச்சு எடுத்து பார்க்கலாம். Yes or no. குயிக்கா. Hello, am I audible?
Yes, sir.
Chat box la, yeah, do you want us revision or not? Yes or no? Quick. நீ எதுவுமே டைப் பண்ணலாம், எனக்கு என்ன ஃபேவரா இருக்கோ அதை நான் எடுத்துக்குவேன். ஓகே, ஒரு எஸ். மீதி பேருக்கெல்லாம் chat box ஆக்சஸ் பண்ண முடியலையா? சரி, ஜெயதேவன் சார், அங்க chat boxல ரெஸ்பான்ஸ் இருக்கவங்களுக்கு மட்டும் அட்டெண்டன்ஸ் போட்டுருங்க சார். ஓகேவா சார்?
Okay, sir. Okay.
இந்த கிளாஸ்ல 4 பேருக்கு அட்டெண்டன்ஸ், இந்த கிளாஸ்ல சித்தேஸ்வரனுக்கு மட்டும் அட்டெண்டன்ஸ். இது நம்ம ஆளுகள் வந்து மார்க்கு அட்டெண்டன்ஸ் இதுக்கு மட்டும்தான் வயர் திறப்பாச்சு. பார்க்கலாம் அட்டெண்டன்ஸ்க்காவது எல்லாரும் எத்தனை பேர் இன்னைக்கு வரான்னு பார்க்கலாம். எல்லாம் காப்பி பேஸ்ட் பண்றீங்களாடா? ஒரு எஸ்ஆ எடுத்து ஒரு நோ சாரையும் காணும். நோ சார், we can study ourselves. வெரி குட். உதயராஜன் தான். அப்போ நம்ம அந்த கிளாஸ்ல வேற ஏதாவது கூட பண்ணலாம் அப்படின்றான். ஓகே, ட்ரை பண்ணலாம். ஓகே, ஐ வில் வெயிட் அப் டு எண்ட் ஆஃப் த செஷன். அதில் எது மேக்ஸிமம் இருக்குன்னு பார்த்துக்கலாம். எஸ் மீன்ஸ் ஆப்வியஸ்லி செமினார். ஓகேவா? எஸ். லெட் மீ கெட் இன் டு த நியூ டாபிக். நியூ டாபிக்னு தெரியும், ஓல்ட் டாபிக். Yes, can anyone recollect the very initial classes of your MOSFET and tell me, we especially we discussed 2 applications of the MOSFET in the very initial slides. Can you recollect that application and tell me? Any 2 applications of your MOSFET. What will be the first application? Any 2? Yes.
Switching circuit.
Switch transistor as a switch. Okay, then amplifier. So amplifier input. Actually, now we are going to do 2 things. We are going to learn the new, but we are going to learn the new with the idea of the previous one. Thereby, BJT revision, amplifier revision also going to happen in the same class. Okay, wow. So BJT amplifier revision, indirectly we are going to learn it from the MOSFET. Okay, yes. Please tell me, in BJT, whenever we are talking about this application, we will have this waveform and we will mark some regions and we will tell. Can anyone recollect and tell me those regions, please? So regarding the output characteristics, am I correct? So output now, if it is a common emitter bias, so the output terminal எதுவா இருக்கும்? Emitter to collector இருக்கும். இங்க என்னவா சார் இருக்கும்? Collector current. Yes, tell me, we are focusing on We studied 3 regions in this characteristics. Can anyone tell me what are the regions?
Cut off saturation.
This is cut.
Active region.
Okay. What about this region?
Cut off.
Cut off.
Cut off.
Open switch. What about this region?
Saturation. Close.
Saturation region.
Closed switch. What about this region? What about this?
Active region.
Active region is for amplifier. Okay, what? Amplifier. Very simple. So here also we are going to have these 2 applications. Since it is under the transistor family, the characteristics are little similar. Okay, there may be a little slight deviation in minute characteristics, but application wise it is going to perform almost similar. Okay, yes. Now you can come to the MOSFET. MOSFET, you know 2 characteristics. What are the 2 characteristics, sir? What are the 2 characteristics? Okay, let me draw. You spell what is the name of the characteristics.
Drain and transfer.
Drain and transfer.
Very good. Drain and transfer characteristics. So your drain characteristics is also called as VDS. This is ID. These 2 parameters falls in input circuit or output circuit.
Output.
So the drain current is also called as output characteristics. Okay. Then this is the transfer characteristics. I hope this is clear to everyone. The diagrams are clear. From this I need to find the application. So in which region my MOSFET is going to operate as an amplifier and switch I need to find. Before that, in drain characteristics, we learn 2 regions. What is these 2? Can you tell me? Please turn your pages back and tell me what about this A and B? What about this A and B? Please take your pages back and tell me.
A is triode, B is saturation.
Very good. A is the triode region. B is the saturation region. Okay, wow. Then and one more thing. This is actually regarding D MOSFET. Okay, wow. We will have a E MOSFET transfer characteristics. It will be more clarity to discuss. Tell me. This is my VGS and this is my ID. Up to this, there is no current flow in the device. Am I correct? My ID is 0. Up to this, my MOSFET will act as a closed switch or open switch. Option A, option B. Please focus this area. And tell me. Let me erase this graph. And our revision mari eduthuko, think panni answer sollu. And also I will ask few more questions in this. Okay, first of all, what is this point? After this voltage, you will find rapid increase in the current. What is this point? Very good. Threshold. Before threshold voltage, my MOSFET will act as a open switch or closed switch.
Open switch.
After threshold,
Closed switch.
அப்போ வந்து MOSFET வந்து எங்க சுவிட்ச் ஆக்ட் ஆகுது அந்த போர்ஷன் எனக்கு அழகா கிளியரா புரிஞ்சிருச்சு. ஓகேவா? Now I need to focus on only this amplifier region. Amplifier region. So amplifier region எப்படி work ஆகுது? That we will see in the consecutive slides. Before that, as usual, here I have a 3 terminals. Here I have a 3 terminal: source, drain, and gate. Source, drain, and gate. Using these 3 terminals, I will be having 3 combinations of circuits. By having any one of the terminal as the common for both input output, I will be having 3 different circuits. Can anyone name those 3 modes? First, you recollect your BJT and tell. BJT you have 3 terminals: collector, base, emitter. These are 3 configurations we have studied based on the common terminal for the input and output. Can anyone tell me what are the 3 configurations we have studied in BJT?
Common base,
Common source, common base, and common emitters.
Okay. Common base, common base, common collector, common emitter. Which one is more having a wider application? That is your common emitter. Now you come here and tell me, please follow the same order. இங்க பேஸ்க்கு ஈக்குவலண்டான டெர்மினல் இங்க எது?
gate,
அப்ப காமன் கேட். ஓகே. தென் கலெக்டருக்கு ஈக்குவலண்டான டெர்மினல்
drain,
ட்ரைன். ஓகே. தென் எமிட்டருக்கு ஈக்குவலண்டான டெர்மினல்
source, common source.
Now you tell me, out of these 3, which one we will use?
Common source.
Common source.
We will use all the 3 combinations, but comparatively this is having a more advantage. Okay, common source. Why? Tell me in next class. Find and tell me in the next class. Okay, wow. Shall I give it as a small task to people? Find why common emitter is more popular, and then you find why common source. A section, find this. B section, find this. Okay. Next class, you need to tell the answer. Okay. Yes. Now we will focus only on what? Common source amplifier. So as usual, first I need to find how I need to make this configuration, then its operation and its characteristics and small signal model. Now, I want to tell you one thing. In the unit test, they asked one question that draw the circuit diagram of the 2-part network. அப்படின்னு கொடுத்திருந்தாங்களா? Equivalent circuit diagram of a 2-part network. Equivalent circuit diagram of the 2-part. அதோட மாடல் கேட்டிருந்தாங்க. கரெக்டா? இப்போ மாடல்னா இந்த பாக்ஸ் அதை வரையணுமா, இல்லை அந்த பாக்ஸ்க்குள்ள என்ன இருந்து டீட்டெயிலா வரையணுமா? விச் ஒன் இஸ் கரெக்ட்? அந்த கொஸ்டின் இருக்கா கையிலையாவது? எது வரையணும் கண்ணா?
Sorry, it was H parameter only. Parameter equivalent.
H parameter equivalent of the 2-part network. H parameter equivalent ன்னு கேட்டிருக்காங்க. அப்ப is it sufficient to have only this 2-part network block once again? No. இதுக்கு அடுத்த ஸ்டெப்ல இருக்க டயகிராம வரையணும். கரெக்டா? So many of them drawn only this block. Okay, so they asked the H parameter model na இதுக்குள்ள இருக்கிறது. கரெக்டா? This thing you need to draw. So semester examல அந்த mistake பண்ணாத. Whenever we are correcting your answers, only one person clarified this doubt. Others வந்த வரைக்கும் லாபம் எடுத்து வச்சுட்டு உட்காந்துட்டு இருக்கு. கரெக்டா? என்ன மிஸ்டேக் பண்றேன்னு தெரிஞ்சுக்கோ. அப்பதான் ஃபியூச்சர்ல எங்கேயாவது அந்த மிஸ்டேக்கை பண்ணாம இருப்பேன். ஓகேவா? யூ நோ ஸ்மால் சிக்னல் மாடல். ஸ்மால் சிக்னல்ல we won't bother about the frequency. small signal the amplitude வந்து minimal millivolt இது மாதிரி ரேஞ்சில் இருக்கிறத we will amplify it and we will use it to our application. Okay, then the last one is the frequency response. Frequency, can you remember the frequency response curve? Okay, let me show 3 or 4 options again. So this is the change in frequency versus amplitude in decibel. Okay, in decibel. Option A, this. Option B, this. Option C, this. Option D. Which one is the frequency response to your bipolar junction transistor in single stage amplifier? Option A, B, C, D.
C, sir.
Option C, sir.
Option C. Whoever knows option C as the answer, it is very easy to you. Here also we are going to have the same characteristics, same theories. Okay, only the thing is only the letters will vary. Anga G irukum, S irukum, inga D irukum inga. There you have a emitter based connector. Then that is a current control device in BJT. Here it is a voltage control. Paklama, very first one. So this is the thing I have to, we have discussed in earlier. கண்ணா நீங்க யாராவது எனக்கு ஒரு ஐடியா சொல்லுங்களேன், நம்ம ஆல்ரெடி படிச்சதை வச்சு சொல்லுங்க பார்க்கலாம். ஸோ என்னோட இந்த ரீஜன்ல ஆக்டிவ் ரீஜனா எனக்கு எது ஒர்க் ஆச்சு? பிஜேடியில் ஆம்பிளிஃபையரா ஒர்க் ஆச்சு. இங்க அப்ப எந்த ரீஜன்ல ஒர்க் ஆகும்? Can anyone tell me what is the name of the region? அவ்வளவுதான் சார், that's all. What is the condition? What is the condition to that? What is the condition I need to remember?
Voltage across drain source is greater than override voltage.
That's all, sir. It is not a override voltage, over drain. Okay, okay. Over drain voltage. Please take this hint, is very, very important. Only in this region we are going to operate it as a amplifier. That too, this VDS value must be greater than your over drain voltage. Then only your MOSFET will act as an amplifier. That's all. Okay, amplifier. So amplifier what is the input element? What is the output element? Example we have discussed. BJT input என்னவா இருக்கும், output என்னவா இருக்கும்? Input is hello hello, output is hello. அவ்வளவுதான். Mic and speaker. Mic வந்து என்னது சார்? Mic is speaker,
Output, sir.
output. Okay, now this thing, you know, 3 types available, but only one important thing is common drain have alternate name as source follower. So upon examination, if they ask you to explain about the source follower, don't get confused with these 3. Write it down. The other name of common drain is source follower. Okay. Yes. Remaining things are similar. We discussed already. Am I correct? So we will be having one common terminal, common for both the input and output. Here source is the common. Here drain is the common. Here gate is the common. Okay. So அந்த theory தான் இங்க எழுதியிருக்காங்க. Yes. Yes, sir. So signal ground நீங்க கொடுத்திருக்காங்க. Signal ground. Can you watch this 3-pin plug? Can you watch this 3-pin plug in the camera? பார்க்க முடியுதா?
Yes, sir.
இதுல ஒரு பாயிண்ட் இருக்கு, அது என்ன பாயிண்ட்? அது bigger one.
Earth point, sir.
எர்த் பாயிண்ட். அதையும் கிரவுண்ட்னு சொல்லுவாங்க, கரெக்டா?
Yes, sir.
கிரவுண்ட்னு சொல்லுவாங்க. அப்ப சிக்னல் கிரவுண்ட்னா என்ன சார்? சிக்னல் கிரவுண்ட்னா, so signal groundன்றது ரொம்ப சிம்பிள். your mic have 2 terminals. மைக்ல 2 டெர்மினல் இருக்கும், ஸ்பீக்கர்ல 2 டெர்மினல் இருக்கும். So usually it is set as a plus minus plus minus. Okay, wow. So you will be having amplifier circuit and biasing circuit, everything. So the positive terminal is given as an input and the positive la poirum. And the negative irukku pathingala, this and this. இதை காமன் பண்ணி இதுக்கு ஒரு சிம்பிள் டிரா பண்ணோம்னா அதுக்கு பேரு சிக்னல் கிரவுண்டுன்னு பேரு. என்ன கிரவுண்டு? சிக்னலோட லோ பொட்டன்ஷியல் டெர்மினல்ஸ் நம்ம காமன் பண்ணும்போது அந்த இதுக்கு பேர் என்னது? சிக்னல் கிரவுண்டுன்னு பேரு. ஸோ கம்யூனிகேஷன் சிஸ்டம்ல சிக்னல் கிரவுண்ட் இஸ் வெரி வெரி இம்பார்ட்டன்ட். ஓகேவா? ஸோ திஸ் இஸ் இந்த ரெண்டு சிக்னல், இங்க ஒரு இன்புட் சிக்னல், திஸ் இஸ் மை அவுட்புட் சிக்னல் ஆம்பிளிஃபைடு. ஸோ இது ரெண்டுக்கும் காமனா ஒரு பாயிண்ட் இருக்கும், தட் இஸ் யுவர் சிக்னல் கிரவுண்ட். ஓகே, இஸ் இட் கிளியர்? இஸ் இட் கிளியர்? ஐ ஹோப் இட் இஸ் கிளியர் டு எவ்ரி ஒன். அந்த சிம்பிள் வேணா நோட் பண்ணிக்கோ. சிக்னல் கிரவுண்டுக்கு இந்த இப்படி வரும், நார்மல் கிரவுண்டுக்கு இப்படி இருக்கும். இதெல்லாம் உங்க 12th புக்லயே இருக்கு. ஓகேவா? எஸ், now we will come back here. எஸ், நம்ம கிட்ட MOSFET இருக்கு. இப்போ MOSFETல என்னெல்லாம் பண்ணணும் சார்? we need to connect a input. கரெக்டா? we need to connect a input. then இது என்ன கான்ஃபிகரேஷன் வச்சுக்கலாம்? என்ன கான்ஃபிகரேஷன் வச்சுக்கலாம்? காமன் சோர்ஸ். அப்ப இந்த டெர்மினல் எதுல, இந்த ஏரோ ஹெட் எதில் ரெப்ரசன்ட் பண்ணிருக்கும்? சோர்ஸ்ல இருக்குமா, ட்ரெயின் டெர்மினல் இருக்குமா? சோர்ஸ்ல இருக்கும். So let me keep it as a common. Input, what you will connect? You will connect your mic. Okay. Then output la I need to connect my speaker. Is it only these components are sufficient to make an amplifier, or else is anything I need to connect it to bias my device? Bias பண்றதுக்கு தான் நான் கனெக்ட் பண்ணுமா?
It's a DC source we have to connect to biasing.
How many types of biasings are available? Based on the type of MOSFET used, you are having different biasings. So the well known is what? Voltage divider. R1, R2. Then you have one resistor here and one more resistor here. Then this is your load. So here I am applying DC as for biasing. But in the signal I am giving AC. Are you happy if these two are mixed together? DC inga AC la inga mix aglam, inga mix aglamna, are you accept? Are you accept to mix the DC signal with your AC signals?
No, sir.
Then how to isolate this? What is the component I need to use, or what is the component already we have used in the BJT?
Capacitors.
What is the name of the capacitor, sir? Let me put it one capacitor. Bypass capacitor. Bypass capacitor இங்க எமிட்டர்ல இந்த இடத்துல போட்டுருப்போம். இது எதையோ ஒண்ணு bypass பண்ணும். இது எதையோ ரெண்ட கப்பிள் பண்ணுது. இன்புட்டையும் இதையும் கப்பிள் பண்ணுது. Therefore it is called as what?
Input coupling capacitor and output coupling capacitor.
That's all, your honor. Take down this diagram. And we will go for the lunch. Take one more capacitor in output circuit also. Then assume you are having one load, that is this is your speaker RL, this is your mic input, this is your biasing. Okay, this is the voltage divider biasing. You know the function of these two capacitors. Take down the circuit alone and go to the lunch and read your amplifier portion and come to the next class. We will discuss in detail. Okay, thank you very much for your patient listening. Who ready to take this seminar, please stay back. And also you have one SAR gave one project to you people. If you want to discuss related to that also, you can stay back. Yes, only these many students will get attendance, don't mistake me. Let me tell the name who are all going to get the attendance. 10 பேர் தான் இருக்கு. அவன் நினைப்பா நீ எப்படியும் 10 பேர்த்துக்கு ஆப்ஷன் போட மாட்டேன் அப்படின்னு, அட்டெண்டன்ஸ் போட மாட்டேன், எல்லாத்துக்கும் போடுவேன்னு. அப்படிதானே? சரி, ஓகே.